Okay. So till this point, we have studied how to get the average and do the percentage mathematical phi operations. Now we will see what is the increment and decrement operators. So along with those standard plus operations, we have this plus plus a. Okay. Now this plus plus a actually increments the value and store it at the same location. Similarly, minus minus b, and whenever you see these two operators are prefixes, then they do the operation and then they store the values. Whereas if they are postfixes, then they will perform after the value is stored. So remember that is a difference between prefix and postfix. So here you will see that plus plus change the value of a from 10 to 11, b minus minus change the value of b from 100 to 99, then c plus plus has exactly incremented in one counter digital one, that is integer value. So 10.5 becomes 11.5 and d 100.5 becomes 19.5. So we will learn how to or what is the basic difference between post and pre. Remember, whenever it is pre, the operation is done before the storing of value, and whenever it is post, the value of a is first stored and then the operation is carried on to the a. So let's see what are the assignment operators. So assignment operators could be simple equal to, where you can just say a equal to b or a equal to 3, 5 equal to 7. Okay, that you cannot do because that is a wrong statement. Then you can only assign variable with a value. Like a equal to b is okay if only b is having some value declared earlier. Then plus b is basically a equal to a plus b. So this is the example. Then minus b it's the same as a equal to a minus b. Next is a into equal to b, that is a equal to a into b. A slash equal to b, that means a equal to a divided by b, and a percentage equal to b is same as a equal to a percent b. So these are the assignment operators. Now let's try and understand one code on assignment operators. Let's say include stdio.h int a equal to a comma 5, and then there is a c variable declared. Now what they are doing is c equal to a, that means assignment operator. So c will be loaded with the value of 5. Print c will display value 5. Then c plus a. So this will be c equal to c a plus c, which is equal to 5 plus 5. That's why it is 10. Then printf c minus equal to a. So again 10 minus a. So that is equal to 5 again. Then c into equal to a. So c is 5 into 5, that's why 25. Then c divide equal to a, that is nothing but 25 by 5, which is again 5. And then c modulo equal to a, that is 5 divided by 5, whose modulo will be obviously 0. Then next is relational operator. So now relational operator will allow you to find whether the relation is true or false. If value is true, then it will return 1, otherwise it will return 0. So equal to, greater than, less than, not equal to, greater than equal to, and less than equal to. So for the top 5 subjects out of 7, this is one of the most important paragraph, that is relational operators, because here we can compare and relate the two objects together. So for example, here is one program where we are writing int a equal to 5, b equal to 5, c equal to 10. And now we are saying uh, a comma b, that is 5 equal to 5 is, then we are saying a equal to b. So if this value is true, then it is saying 1. So here you will see 5 equal to 5 is 1. Next line is percentage d equal to percentage d is percent d, where a comma c and a equal to c. So 5 equal to 10 is not equal, and that's why it is saying 0. Next is percent D greater than percent D is percent slash N. So A comma B is A greater than B. So 5 greater than 5 is wrong. Remember, it's greater than relation, not greater than equal to. Whereas here at the bottom, you will see 5 greater than equal to 5 is 1. So it's the same code written in multiple ways. I will not go line by line, but basically we are checking equal to, then greater than, then less than, then not equal to, then greater than equal to, less than equal to. Next is logical operators. So logical operators means if they are both are true, then your final operation is true. For example, and. Okay, logically, if C is equal to 5 and D is greater than 5, then you have to give this particular and statement to be true, else it is false. So or means any one of them is true, and is both of them are true, and not is if that statement is totally not true. For example, not C equal to 5. Here is example, if C is 5 and D is 2, we get an expression that C equal to 5, which is true, and D is greater than 5, which is false. Then this ampersand makes the entire statement false because though the C equal to 5, D is not greater than 5. Whereas in the case of OR, since C is equal to 5 or D is greater than 5, either of the statement is true, output is 1, and in the last case C is 5 and we are saying not C equal to 5. So C equal to 5 is true and not of that is false. So some of the examples with that is logical operators include stdio.h main A equal to 5, B equal to 5, C equal to 10, and now we are checking results. If A equal to B, which is true, and C is greater than B, which is again true, then printf the answer percent %d as a result. So true and true is always 1. So this particular command will give a result 1. So here you can see A equal to B and C greater than B is 1. Next command is A equal to B and C less than B. This particular statement is and having one of them as false statement. So your final answer is false because it was ANDing operation. Next is A equal to B and C or C greater than B. Either of the statement is true, that is A equal to B, and that's why your final result is having value 1. And similarly, not equal to odd with C greater than B, both are false. So your final answer is false. Then not of A, not of B. So what does this statement means that if A is not equal to B, which is false, and not of that will be true, hence final result will be true. So that's why this final result is true over here. And the last operation is not A equal to B is 0. Now, expression of logical program operator, like we have studied and, or basically true and false. These are the logical program operators. Next is bitwise operators. Now, they are very similar to the logical statements. Here you will see a single ampersand for bitwise ending, single or for bitwise ORing. Then this particular symbol, which we generally use for power off, is for bitwise XOR. Now, what is a bitwise XOR? We will try to understand with the help of a power paint. So, what do you mean by XORing operation? Basically, if both the values are 0, then output is 1. Either of the value is 0, then output is 0, and if both the values are 1, then output is 1. So this is the combination of and it's a combination of OR get output. So this is a truth table for the XOR. For example, if my first statement is false, next statement is false, and then I do XOR operation between these two, then the output will be high. But if my first operation, either of first or second operation is false and other operation is true, then your output will be low. And at the end, finally, if both the operations are true, then also your output is high. Whereas in AND operation, if you have both outputs as 1, then only your final output is 1. So in this case, everything will be 0, 0, 0, but this final output is 1. So this is condition A, this is condition B. So I think it's different for your regular operations. You might have studied this in your 12th standard, that is
Sir,
AND OR operation. Yes,
sir, isn't XOR the opposite?
I have to check. Is the XOR opposite? I
Yes,
think
sir.
so. This is XNOR, and then
This is
XOR
XOR.
is yeah. Let me just verify. XOR truth table. So either of them is true, then output is high. That is what we call a XOR operation. Let me check where is XOR. Yeah, you are correct. This is XNOR. So 0, 1, 1, 0. And is there any XNOR output there? Yeah, XNOR is 0, 0 will give you 1. So basically, this particular bitwise exclusive OR. So it's exactly reverse way. Sorry for that. I got confused. So this should have been 0. This should have been 1. And finally, it should have been 0. So when both operations are not correct, you get a 0 at the output. When both operations are correct, you get the 0 at the output. And if either of them is true and other is false, then your output goes high. That is what we call it a bitwise XOR operator. The next is bitwise complement. So this is just inversion. So if it is 1, it will convert to 0, and if it is 0, it will convert to 1. Then you have shift left and shift right operator. So what do you mean by shift left? If you have 1, 1, 0, and if you try to shift, then this particular one will go to there, this particular one will go to there, and then this particular 0 will go to here. So if you shift this, it will, there are two kinds of shift. One is a complete rotational shift where the last bit is not thrown away, but it is rotated and put at the first position. And then we have non-rotational where the last bit is thrown away and new value is only 0 added. So it depends on what kind of binary operation you are doing. Anyways, in this particular case, it is not very clear because this will produce 0, 1, 1. So it is not very clear that this last one was swept and put it here, or was it discarded. So let's take another example where it will be very visible for us. If this is the original number and if I call the shift operation, so this 0 will go there. So if I getting 1, 1, 1, 0, then it's a last bit carried to the first value. And if we are getting 0, 1, 1, 0, then you are actually throwing off the last bit, which is this one, and adding a 0. So typically this operation is done so that you get rid of lower or non-significant bits and you only can focus on the higher significant bits with the less number of memory operation. This rotation operation is useful for rotating the stepper motors and so on, but these kind of operations are not preferred. These kind of operations are preferred because they compress the data. We will learn about these operations later in the programming. Next is other operators, which are comma operator. Now if I write int a comma c equal to d, so this will basically split a as a separate integer declaration. Next is it is common, so c equal to 5 will be declared in the next int operation, and then int equal to d. So comma will basically separate out the individual expressions multiple times. Then size of operator, we have already seen it earlier when we displayed the size of int, float, double and char. Same code we wrote at the end of lecture 1, I guess. And so till this point, we have learned about variables and constants. We have learned about data types. We have learned only two basic commands for input and output, that is printf and scanf. And we have learned about multiple operators. Okay, so now we will look at the basic programs one by one from tomorrow's lecture. on these particular topics that we have learned, and then we will continue with the loops. So if you have any doubts, you can ask. Otherwise, we will end the lecture now.